Okay, well, we kicked Miss London off of these next couple of videos. So Miss Hussein and I are
We're
back
back.
to talk about exponential transformations over here in trailer, what are we, T10?
10.
10?
Yes.
All right, T10. It's a good place to be. All right, so let's go through these pretty quickly. All right, so first we start with our parent function.
So the parent function is basically what's the bare bones of it. First, we need to figure out if it's a growth or a decay.
Right.
And what actually determines the growth and decay?
Well, our B term here determines our growth or decay, and we need to see, since we know we don't have a negative B term, our growth function has to be any B that's greater than 1.
So it
Okay.
can't be equal to 1 because that would make it a horizontal line at 1.
Yep.
Can't be 0 because that'd be a horizontal line at 0.
Exactly.
Not exponential anymore.
Exactly. So our B term, we're taking it to a positive exponent, so it's getting bigger every time. And our decay function, then our B, since it can't be 0, we have to be bigger than 0, but can't be 1, so we're going to be less than 1. So any fraction or decimal, which are the same thing, would make it a decay function. It's decreasing, it's being divided each time.
Right. So for example, for a growth, we could have, something that triples or quadruples. So that would
like
be a
3
B
to the
of
x.
3 raised to the x.
Yeah.
That's our common ratio, so to speak, in terms of our geometric sequences.
Yeah, and when our decay, we make it, 1/3 to the x. Put that in.
So each time you're decreasing by
Yeah,
2/3 here.
correct. All right, so now we can move this parent function around using a whole bunch of transformations. So our first one, we're going to term our stretch term. Okay, this is also the term that is it's the term that stretches our function towards or away from the y-axis. All right, so if you think of a rubber band, you're pulling your function upwards and it's moving it closer or further away from that y-axis.
And if you get confused by looking at the whole graph, you can just take a look at one point. So maybe take a look at the y-intercept. So y-intercept of something without an a term would be, for example, if it's just 2 to the x.
Yeah, if it was just 2 to the x, we'd plug in 2 to the 0, so our y-intercept would just be 1.
0, 1. So then what happens when we have a 3 in front of it?
Well, when we have a 3 in front of it, we'd have our 3 times 2 to the x. So 3 times 2 to the 0, which is 3 times 1, or 3.
So that y-intercept got stretched from being at 1, and now it's up at 3. So there's our stretch.
So if there's no other transformation on here, I could term this a term as the y-intercept.
Yeah. If there's nothing else shifted.
Yes.
Right?
So you do have to be,
up and down.
Yeah, you do have to be careful if you start doing one of our other horizontal or vertical shifts. That y-intercept is going to change. But if there's nothing on it and we're in our a, b, x form, which is what we saw with our geometric sequences.
Exactly. A was our y-intercept, or our 0 term, and b was our common ratio.
Yes. So that can be our y-intercept. So let's just look at it. What an example would be here if I would graph this guy. Okay, so I know 3 is my y-intercept. So I'll put a little dot at 3. And then we want to do a couple points, probably either way. So if I plugged in, so I'm going to make my little chart here. Let's try it like -1, 0, 1, and 2. So 0 was 3, x, f of x.
So you can plug it in, or you can think of it as a geometric sequence that we were doing before.
Right. So if I plugged in y here, I would get 3 times 1/2, because it would actually move it to be in the denominator, and 3 times 1/2 would be 3 halves. So 3 halves would be 1.5, so right about there. Okay. 2 times 3 would be 6.
And then the next one would be 12.
12. Sorry, going slow. Move it that way. So
way up there, yeah.
We're gonna look. Woo.
So we have some asymptotes here, don't we?
Yes, we do.
Or just one.
Where is our asymptote, Mr. Hussein?
I would say it looks like the x-axis.
Yes, so our x-axis, or y equals 0. Okay, that is our
So if
Nice
we have a
little
y
horizontal
equals
axis.
0 as our asymptote, does that mean we have an x-intercept?
No, it does not.
No x-intercept, but it has a y-intercept.
Yes.
It's supposed to hit that 3 point, so we've got a couple key things there.
Mm-hmm. Yeah, so key features, definitely always telling us where your asymptote is, where your y-intercept is, and then if there is one, you can plop in an x as well.
Talk about domain and range too. So looks like our domain here would be all real numbers, right? Left to right, there's no breaks in between. And our range looks like we can't have anything below 0.
So pop that down. So all real numbers, and yeah, our range would be y is bigger than 0.
Not equal to.
Nope, does not hit that line. All right, so there's your stretch term. Okay, well, what happens if I make that stretch term a negative number?
Well, if you can't remember the rules, I just go ahead and plug some numbers in. So let's see what happens.
Okay. So here's my x, f of x. So let's do negative 1, 0, 2, I'm sorry, 1, 2, 1 comes after 0. Okay, so if we plugged in negative 1 here.
That makes 1/2 to the negative 1, which is 2 over 1, so 2.
All right, so we get negative 1, sorry, 1/2 to the negative 1, which equals negative 4 times 2.
Negative 8, there we go.
Negative 8, okay. Negative 4, 1/2 to the 0.
Just negative 4.
Negative 4. Negative 4 times 1/2 to the first. It's just
so
1/2.
Negative 2.
Negative 2. And the last one, negative 4 to the 1/2 squared.
Negative
1.
That's a good start.
Okay, so looks like we have a bunch of negatives here. I'm used to staying above the x-axis. I don't know what's going on here. Well,
let's take a look.
So our y-intercept we saw was at negative 4.
So that's where x is 0.
Okay, so at 1 we were at negative 2. At 2 we were at negative 1. And then we were way over here at negative 8. So we kind of came in.
Are we going to hit that x-axis?
We are still not going to hit that x-axis.
Still not going to happen.
Okay, we haven't moved that asymptote at all. So that's
So if you
still
think
there.
about it, our multiplier here, or our common ratio is 1/2. So we just keep having that number here. So you'll see the negative 1 just keeps getting smaller and smaller, but it's never going to hit.
Exactly. Now normally this would be a decay function moving down. So what happens is this negative number reflects it across the x-axis.
Right.
So you imagine it being flipped over.
Right. So we've taken a decay function, flipped it over, and it looks like it's growing, but we're not going to call it a growth or a decay.
No.
Growth and decays are only defined in that first and second quadrant.
Correct. This is just some reflected nice little...
But it's still exponential, so it's a it's a miscellaneous exponential, I guess.
Man, just creating more and more categories.
Yeah, exactly.
All right, so that's how we'd figure out our reflection. Well, what if I made the exponent negative?
Oh, wow.
I know, now I'm really blowing up the system.
Exactly. So, well, if your mind's blown, maybe just plug in some points.
Okay, well, let's imagine it's not negative. So first we could sit there and say, okay, so our parent function, we would cross it here.
2 to the x, so
And
that's just a regular old
2
growth.
to the first,
doubling,
2 squared, all the way up here. So it would just look like this, all right? So here's f of x equals 2 to the x.
Right.
So now I'm going to make it f of x equals 2 to the negative x.
So let's try it. If we put in 0.
Well, negative 0 is still
0.
So my
y-intercept's still there.
intercept's still the same.
Let's put in positive 1 here.
All right, positive 1
So 2 to the negative 1 would be
equals
1/2.
1/2.
Okay.
Ooh.
And let's go backwards. Let's do negative 1.
2 to the
Negative 1.
negative 1 is 2. Because negative and negative make a positive 1.
Right.
And so now we're at 2. So what's happened here is it reflected it not across the x-axis, but across the y-axis.
Exactly.
Okay.
So negative exponent, that negative in front of the x reflects it. Basically took all your positive x values and made them negative and vice versa.
Yeah. The other way you think about it is we changed it from a growth to a decay function. Because a negative exponent moves our exponents to the denominator. And
so what's another way to write that 2 to the negative x?
You could write it as 1 over
exactly.
2 to the x.
Or you can
or
write
just 1/2 to the x.
1/2 to the x as well. Yeah,
Sorry,
those are all the same.
Distributing.
Right.
But keep our
so we can see
consistent.
our factor.
Yes.
Mm-hmm.
All right.
Or decay factor.
Right. So it's a way of switching between the two, growth and decay.
Exactly. So don't be fooled just because you see a 2 there. Think that it's a growth.
Right.
If you see a negative exponent, it's actually 2 to the negative 1, which is 1/2 as your common ratio.
Right. Which is why we always tell you guys in class we love positive exponents because it takes away that confusion that can come around. All right. So I think we've had enough of our reflections.
Let's do some moving about.
Yeah, let's shift this thing. Okay, so here we go. Ooh, it says horizontal shifts. So if my C value, so our C value is what's added to our parent function.
Exactly.
So we have bx plus some C value.
Right.
Okay, so if a C is greater than 0, we shift it to the, that's wrong, that should go left.
Oh dear. All right, yep, that
Typo.
goes left.
That's what happens when Mr. Lewis makes this late at night. All right, and when it's negative, it should actually go to the right. They are backwards. Hopefully he did not make that mistake on the vertical shift page as well.
Let's see.
Okay.
Well, let's take a look at the example. This is 2 to the x minus 3. So
okay.
the parent function is 2 to the x.
Yeah, so we can plop our 2 to the x, which we knew from last time. So here's 2, 3, 4, 1, 2. Okay, there we go. So here's our parent function.
Here we go.
Going like that. All right, so we are now going to shift this. So since this is a negative 3 means I'm going 3 to the right because I take the opposite sign.
Yep.
Okay, so I was here. So if you think about it, we were at
that original y-intercept
0,
got
1,
shifted, right?
Right, and we were going to shift that 1, 2, 3. It is now going to be here. Okay, so every point gets moved. So I'm going to move this guy over 3. I'm going to move this guy over 3. I'm going to move this guy over 3. So here I'm at 2. Here I'm at 4. So here I'd be at a half, a fourth.
And still don't cross that line.
Nope, never. So the question would be, where is my new, so my y-intercept here, oops, y-intercept equaled 1. What's my y-intercept here?
Good point. How do we calculate it?
Well, we would plug in
x equal to 0.
0 minus 3. So we get 2 to the negative third.
So that's 1 over 2 to the third power. 1/8.
1/8.
So it looks just about right. That looks like 1/8 there.
Right. So don't take, again, we would normally take our a value, which is here 1.
Exactly.
But our a value changes because of this shift. So this is
everything. Yeah.
This is why we told you guys in the earlier slide to watch out for that. Don't always take that that's the y-intercept. Right. Okay. We good on our shifts?
I think so, yeah.
All right. Last one. Man, there's a lot of shifting going on here. It's pretty shifty stuff. Okay. Ooh, I think I did this one right. All right. So now here we have our parent function b to the x. So if we add on to it some d term, okay, that is our vertical shift.
Yep. So we're just taking that exponential and just either moving it up or down.
Yeah. So remember when you're shifting, you're moving the whole graph. So our asymptote, everything moves up. Okay. So in other words, you can almost think of this as your asymptote now.
Well, our parent graphs had nothing written there, so that was basically y equals 0. Right?
Yes.
So now we have a y equals something, negative 4 here.
Right. So d is greater than 0, I shift it up. D is less than 0, I shift it down. Right. So here I have a negative 4. Well, let's figure out what the parent function looks like.
It's 0,
1,
0, 1, right?
3. Yeah, way up here at 9. Okay.
There we go.
It's hard to draw with this pen. You guys can probably draw much better graphs at home. Okay, so Now we're moving our
Let's
parent
move the
function down.
asymptote. Let's move everything. So the y-intercept that used to be at 0, 1 goes from 0, 1 to now 0,
Right.
negative, let's see, yeah, 0, negative 3, right?
Right, because our asymptote is now here at negative 4. So we're going to move this down to 3. And this one that was at 3 is now at 1. I'm sorry, negative 1.
Mm-hmm.
Oops, I don't know why I'm dotting that. This is my actual graph.
There we go. So it's just the same thing as before on the left, and we just moved it down.
Yep.
4 exactly. So you can see where the asymptote moved 4 down.
All right. There's our shift. Well, that was a lot of stuff.
Let's put it all together.
Yeah, I think we
Okay.
need to put, so these are going to probably be the fun problems that we give you on your test.
Yep. So let's see. What should we do first? Should we first decide if it's a growth or decay? So looking at the B value. So looks like it is a
Okay, so this looks decay-ish.
decay-ish.
The reason I say decay-ish
Yeah,
is
there's
I
that tricky
noticed
negative
there's
there.
that negative sign out there. They really threw everything at us.
Yes, you did.
Okay, so let's figure out where we're going.
So are we going to do the exponent first or multiply negative 2 first?
I think order of operations say we should do the exponent first.
Exponents come before multiply.
Okay, so we were at 0, so we're now going to shift it. It's our, I'm going to say horizontal shift would be 2 to the left.
That's
okay.
Right, that's what I would agree. So it was at 0, 1 before. The original parent function of a regular old b to the x is 0, 1, and now that's moving 2 to the left.
Right, so our 1/3, it was, if we had 1/3 as our normal graph, it'd be here, it would be 1, 3, it'd be here, so it could be this nice little graph that's coming along like this. So I'm going to dot it so we don't get too confused.
Right.
But it might help actually to draw your parent function to see how you guys are moving it. Okay, so we're now going to move this point, over. 2
to the left. So the whole thing's just shifted again.
Right, and then we're going to multiply before we divide. Okay, so this negative 2 then moves it which way?
Down below, and so that was at negative. That was at positive 1 for a y value. Multiply it by 2.
Flipped, it's at negative 1.
And
so
then negative 2.
Negative 2 right here. So now I'm moving it down 2. But then I have this 3, which actually then moves it back up 3. So 1, 2. So I'm actually back up here at 1.
Yeah.
It's weird how I did that. Okay, so we are actually at 1 here. Okay, it's a lot of marker. We got it. It might help to
make a table. Yeah.
Make our table.
It gets confusing.
We do know though that our asymptote here is at 3, so you can draw that in. Okay, so let's plug in some points so we know that this is right.
Yeah.
Okay, so I'm
going to put negative 2 in. I'm going to suggest we start with negative 2.
Okay,
somewhere.
so I know we're at 0, we're at 1. So now I'm going to, okay, so let's go negative 2. Why did you choose negative 2?
Well, I see the x plus 2 in the exponent, so I'd like to get a nice exponent out of that.
Okay, so
let's do negative 2 times.
Hang on, that was actually wrong. What I just wrote in. Okay, let's actually start with negative 2.
Yeah, let's start with
instead of going with 1, so this one's to put in. All right, so this will go to 1. So at negative 2, now we're at 1.
Exactly.
Yeah, see, that's why Miss Suzanne's way ahead of Mr. Lewis. Okay.
Wait a second, do we need to add 3 to it as well?
We did, because if we get this to be 0, so this becomes 1 times negative 2
and then plus
added to 3
there we go.
makes it 1.
Yep. All right, so let's see, negative 1 in here, 1/3 to the negative 1 plus 2.
Okay.
That's
so
1/3.
2, 1/3 to the negative 1 plus 2 plus 3. Okay. 1/3 to the first.
Just 1/3, so negative 2/3.
Negative 2/3 plus 3 would be 2 1/3.
Yes.
Okay. So at negative 1, I'm at 2 and 1/3. So I'm somewhere around here. Okay. Okay. At 0, I am at negative 2, 1/3. 0 plus 2 is just 2 plus 3.
So we get negative 2/9 plus 3.
So which would be 2, negative 2/9 would be 2 and 7/9.
Yeah.
This is some fun stuff. So 7/9.
Looks like we're approaching 3, but we're never going to touch that 3,
Yes.
aren't we?
Right, so I'm going this way, I can see.
Yep.
And
That's just going down.
I could probably say that I'm going that way. That looks like a pretty good graph
Looks
to me.
like it. So we've got our y-intercept at 0 and 2/7/9.
Yes.
And our x-intercept looks kind of crazy, but
So our x-intercept would be where the whole thing would equal 0. So we're going to have to get to a point where the whole thing would equal 0.
We might not be able to find a lovely number for that.
No, that's going to be a really ugly number.
That would be something we'd probably ask you to estimate with your calculator.
Yeah. And
so it's the asymptote, y equals 3, right?
So asymptote, y equals 3. Sorry, pen's slowing down on me. Domain.
That would be everything. Everything's okay here.
Everything. Do it. Our infinities and our range.
Okay, it looks like everything up until positive 3.
Yeah, so negative infinity to positive 3. Okay.
Looks good.
All right, so
We get our y-intercept. We know we do have an x-intercept that we can save for another time because that just doesn't come out nicely.
yeah, so definitely practice with these through some papers that we put on the Blackboard site, and definitely ask us any questions. But I think this is pretty much everything we
It's
got.
a summary of all those transformations. So don't get daunted. Just start small. Start with the parent graph. How do we move it? One at a time.
Yeah, and really, we really highly recommend making that table.
Yeah,
and plugging
worst
it
comes to
through.
worst. Start with, go to the table.
Yeah,
if you need to.
and pick with easy numbers that you guys can do in your head. Don't start with some crazy exponent that you can't do.
Yeah.
Because you need to be able to do it with a 4-function calculator.
Yeah, exactly.